Very good morning, friends. We were dealing with the strategies for peptide synthesis. We need to activate the ester carboxy group to interact with the amino group of the another amino acid. And we have to use carboxy activating reagents to activate this carboxy group. For this purpose, we use coupling reagents to generate the active carboxy esters. The coupling agents which are generally used are DCC and DIC. DCC stands for dicyclohexyl carbodiimide and DIC stands for diisopropyl carbodiimide. By using these coupling agents, we can prepare pentafluorophenyl esters. These are activated carboxy esters. It enhances the reactivity of the carboxyl group, and that's why it increases the susceptibility of it for the attack by the amino group. We take F mark protected amino acid and the carboxy group which is here we activate into an active carboxy ester. We treat with pentafluorophenol and we couple with the coupling reagent either DCC or DIC. We get corresponding pentafluorophenyl ester of the F mark protected amino acid. We can also prepare another carboxy ester which is active, that is ONSU esters, N-hydroxysuccinimide ester. N-hydroxysuccinimides. We take F-mark protected amino acid and treat with N-hydroxysuccinimide and treat with DCC or DIC as the coupling agent, and I will get corresponding N-hydroxysuccinimide derivative. DCC is more effective in solution phase synthesis, but the byproduct which is formed during the process, that is dicyclohexyl urea, is insoluble and it creates problem in solid phase synthesis. When you filter it along with the peptide which is prepared, the dicyclohexyl urea also come into it and separation becomes a problem. That's why the DCC is most widely used for solution phase synthesis rather than solid phase synthesis. DIC byproduct, which diisopropyl urea, is more soluble, that's why it is more suitable for solid phase peptide synthesis. Another problem which these coupling agents DCC or DIC, that's carbodiimides, faces is it gives the racemic mixture. Partial racemization occurs. If we get racemic mixture, it's of no use for us. And we know that the amino acids are all L amino acids. If we get D amino acid and L amino acid mixture, it won't be an active molecule and separation and D and L isomers is again a problem. Right. Let us look into the reaction, how it occurs. F-mark protected amino acid, it first interacts with dicyclohexocarbodiimide. The carbon here is the positive center as it is flanked between two electron deficient nitrogen. The lone pair of electrons and the oxygen attacks on the carbon and the pi electrons moves onto the nitrogen and it becomes corresponding NH. And a CO bond is formed. Then this is treated with pentafluorophenol. OH attacks on the carbonyl carbon. As this is a bulkier group, it becomes easy leaving group and it gives rise to the pentafluorophenyl ester, which is having the activated carboxy group. I can use diisopropyl carbodiimide and we get corresponding diisopropyl amide group, which can be treated with N-hydroxysuccinimide, and I'll get corresponding N-hydroxysuccinimide esters. This esterification reaction which is coupled with the presence of carbodiamides can be extended further by using 1-hydroxybenzotriazole HOBT or 1-hydroxy-7-azabenzotriazole as a coupling additive. It is added as an added addition product to aid the coupling. What this HOBT or HOAT does, it accelerates the reaction process. It accelerates the carbodiimide mediated coupling. Further, we have seen that carbodiimides gives racemic products. In the presence of this HOBT and HOAT, this racemization is reduced. And also, it prevents the dehydration of the carboxamide side chain present in asparagine and glutamine to nitriles. Hence, we use HOBT and HOAT as coupling additives in this carbodiimide coupling reactions. Let us look into the coupling mediated, additive mediated coupling. Carbodiimide reacts with amino acid in which NH group is protected. I'll get corresponding amide form. The benzotriazole OH attacks on the carbonyl carbon and it removes this, and I'll get corresponding benzotriazole oxyester. This can be treated with amine. This amine reacts with the carbonyl carbon and this gets moved away. HOTBT produces activated ester here, and this activated ester interacts with amino of the amino acid and ambient reaction conditions to give the corresponding peptide bond. This is how it aids the reaction process by activating the carbodiimide mediated coupling. As it has its own limitation, we are using other coupling reagents for the purpose of activating the esters. What are those? Will be the subject of discussion for the coming presentation. Till then, have a nice day. Thank you.